Jai Hind. My name is Pardeep and I am working as an assistant professor in IT department in Ajay Kumar Garg Engineering College, Ghaziabad. So today we will discuss the subject theory of computation and formal language, and subject code is KCS 402. Okay. So in short, this is also known as TAFL. Okay. I'm writing in TAFL, Theory of Automata and Formal Languages. Okay. So in today's lecture, we will discuss the deterministic finite automata. So what is deterministic finite automata? So basically, automata deals with the abstract machine, abstract model of computations. And in deterministic finite automata, there are basically 5 tuples, 5 quintuples. Okay. In DFA, in short, it is known as DFA. Okay, and in DFA there are basically 5 quintuple: Q, sigma, delta, Q node and F. So here what is Q? Q is the finite and non-empty set of internal states. Okay, non-empty set of states. Next is sigma. What is sigma? It is input alphabet. It is alphabet or input alphabet. It is a finite and non-empty set of input symbols. Third one is delta. It is the transition function where delta is Q cross sigma applies Q. Okay. We will discuss what is that transition function. Next, fourth is Q node. It is the initial state or start state, and fifth one is the F. F denote the finite and non-empty set of final state, and F is the subset of Q. Okay. So to understand all these quintuple, okay, let's take one small example. Suppose there is one sample deterministic finite automata, this Q node and this QF. Okay, and on A goes to Q node and on B goes to QF, and on A and B goes to QF. Okay, suppose this is small DFA. Why it is DFA? Because here each and every state is defined. So just change the color. Here each and every state is defined. Okay, so this Q node, it is the initial state. Okay, this Q node, it is the initial state. Okay, start state. There is a symbol. Okay, so this arrow is mandatory to show that it is initial state, and these are the transitions. All these are the transitions. Okay, transitions, and this is the final state. This double concentric circle state is final state. This is final state. Okay, now what is Q here? Q is the set of state. So what is Q? Q is Q node and QF. Okay, next what is sigma? This is input alphabet. What are the input alphabet? A and B. So on these input alphabet, language is defined. This is sigma. Next is delta. Delta is the transition function. Okay, what is this? At state Q node, on applying input A, this will goes to state Q node itself. On state Q node, on applying input B, this goes to state QF. On state Q node, on applying input B, this goes to state QF. Similarly, QF on applying input A goes to state QF. QF on input A goes to QF. Similarly, QF on input B goes to QF itself. So these are the three quintuples. Fourth one is Q node. Here Q node is the initial state and this F is the final state. This, what is F? F is the final state and this Q node is the initial state. Initial state. Okay. So these are the 5 quintuple, okay, of deterministic finite automata. And see here, for every input on a state, the transition is defined. Okay. For input A, transition is defined. Input B, transition is defined. Similarly, on state QF, input A, transition is defined, and on input B at state QF, transition is defined. So on every state, for every input, transition will be defined, and there will be only one transition for one input alphabet. Okay, so this is the deterministic. That's why it is known as deterministic, because for every input alphabet on a state, transition will be defined, and for a particular input only one transition will be defined. Means on a particular state, on applying input A, transition will goes to on a particular state. Okay, not more than 2 or 3 state. Okay, so there are few points. Deterministic specifies that transition of a DFA from one state to another state on a given input is unique. That is, there is only one next state, means there is transition function on state Q, applying input alphabet sigma, we goes to only one next state. Okay, so what it mean? So suppose there is state Q node and there is state Q1 and there is state Q2. Okay, just for the sake of example, so on input A, Q node goes to state A, and on input A goes to Q2. Okay, so this is not the case of DFA. Okay, this is not allowed in DFA. This is not allowed. This is not allowed in DFA. What it means? At one particular input, only one, the transition is unique. Okay. Second is null string, that is sigma is epsilon is not allowed. Means in DFA, suppose there is state Q node and on epsilon there is state Q2. Okay, this is not allowed in DFA. In NFA it is allowed, not allowed in DFA. This is not allowed in DFA. Not allowed in DFA. Okay. Third point is, it is necessary to define DFA. This is not DEA, it is DFA for each input in the state. So what it means? Suppose there is input alphabet A and B. Okay, there is input alphabet A and B, and there is transition diagram for DFA at Q node. We goes to state QF on applying input A, and on input A and B we goes to Q itself. Here input B is not defined. On input B where it will go. This is not defined. So this is not allowed in DFA. Okay. So this is not allowed in DFA. So this is not allowed in DFA. Okay. This thing is not allowed in DFA. Okay. So let's see these points again, that deterministic specify the transition of DFA from one state to another state on a given input is unique. Okay. There is only one next state, means that on applying input on some state, there is some state Q and only one next state. Okay. This is very important. Only one next state will be there. Second is null string is not allowed in the DFA. Third point is it is not necessary. It is necessary to define DFA for each input in the state. Okay. So there is one thing, that string acceptance. So what is before going to that? So we know that what is language? Language is a collection of strings. Language is a collections of valid strings. Language is a collection of valid strings. Okay. So here, what do you mean by string acceptance? A string is said to be in the language. Okay. A string is said to be in the language, or a string is said to be accepted by finite automata if upon scanning the entire string we reach from initial state to final state. What it means? Suppose there is state Q node, this is the initial state, this is the initial state, and suppose this is the final state QF. QF is the final state, and there is some intermediate state QK. Okay. So upon scanning the entire string, suppose string is W. Okay. We reach from initial state to final state. We reach on scanning string W, we reach from initial state to final state. Then we can say that string is accepted. String is accepted. Okay. String is accepted. Next, the language acceptance. Next is the language acceptance. So what do you mean by language acceptance? A finite automata is said to accept a language if all the strings, this is very important, all the string in the language accepted and all the string in the language not in the language are rejected. This is very important. A finite automata is said to accept a language if all the string in the language are accepted and all the string not in the language are rejected. What it means? Suppose there is language L and there are various, suppose there are 5 strings. Okay, there are 5 strings S1, S2, S3, S4 and S5. Suppose there are these 5 strings and there is some finite automata. There is some finite automata. Okay, this finite automata upon scanning S1, S2, S3, S4 and S5, all these strings are accepted because all the strings must be accepted. But suppose there are some string S6, S7, okay, and so on, means except S1, S2, S3, S4, S5. Okay, if all these strings are given to the finite automata, then all other will be rejected. Those which are not present in the language must be rejected. Okay, so this is the language acceptance. So let's see some example for construction of DFA. Okay, so let's see, construct the DFA over the input alphabet sigma equal to a comma b such that mod of w equal to 2. What is the meaning of mod of w? Means length of string is, length of string is 2, means length of string will be 2. So here the sigma will be a comma b. Okay, these are the input alphabet. And what is language? All the string of length 2. So the string length of 2 is AB, AA, BA and BB. So all these are the strings of the language. Now we need to construct the DFA such that length of string of W will be accepted. We know that there is some initial state. Okay, so first of all construct of string of length 2. Okay, there is state Q1, on input A and B it goes to state Q1, and on input A and B it goes to state QF. Okay, so at Q node all the inputs are defined. At Q1 all input A and B are defined. At QF A and B are not defined. So this is not DFA. Till now it is an NFA. This is not DFA, but it will accept the string of length 2. Now what about the string input at final state? Okay, so all the other string other than length 2 will be rejected. So if NA, A and B will came, okay, it will goes to the dead state. It will goes to the dead state. Okay, or you can call it as a trap state. Okay, on A and B it will remain in the dead state. Okay, so this is the DFA. Now this is the DFA. Now this is the complete DFA. This is the complete DFA which accept the string of length 2. Okay, now let's see the second example. Okay, construct the DFA over sigma equal to A comma B such that length of string greater than equal to 2. Okay, so here sigma equal to A comma B, and what is language? String of length greater than equal to 2. So it will contain AB, AA, BA, BB, AAB, 3 times A, 3 times B, ABA, ABB, ABBA and so on up to infinite. There are infinite set of string. So for this language we need to construct the DFA. So there is some initial state Q node on input A and B. It will goes to state Q1 on input A and B. It will goes to state QF final. Now till now it will accept the string of length 2 only. Now here the transition is not defined. So if there is transition to itself only, at A it goes to QF only, and at B also it goes to QF only. Okay, then it will accept all the string of length greater than equal to 2. So let's take, just for the verification purpose, let's take W equal to A B B A. Now we are at state Q node. At Q node it goes on scanning A, it goes to Q1. On scanning B it goes to QF. On scanning B it goes to QF only, and on scanning B it goes to QF. So this string will be accepted. Okay. Now let's see the third example. Now construct the DFA over sigma equal to A comma B such that length of string is less than equal to 2. Length of string is less than equal to 2. Okay. So here sigma equal to A comma B, and what is the language? Less than equal to 2 means length will be at most 2. Okay. So length can be 0, 1 and 2. So it will contain epsilon string of length 0, A string of length 1, B string of length 1, AB string of length 2, BA and BB. So all these strings will be accepted by the DFA. So how we will construct the DFA? So it will accept the string of length 0. So initial state will be the final state. Okay. Now it will accept A also, AB also, and so on. Okay. So it will accept AB also. So this is also one of the DFA. Okay, it will accept 0 length string. Now this accept 1 length string. Now on A and B it will accept 3 length string, 2 length string, and now if there is more than 2 A and B of length more than 2, then upon A and B it goes to dead state. Or trapped. Okay, this is optional. Okay, so on dead state, on input A and B, it remains in dead state. Okay, now let's see the construct the DFA such that mod W 2 equal to 0. It means it will accept the string of length, even length string. So there is some initial state Q node and there is Q1. Okay, so on 0 length is also even length, so initial state will be the final state. On input A it goes to Q1, A and B, and on Q1 it come back to Q node itself. So 0 length it will accept, 1 length not accept, 2 length accept, 3 length not accept, 4 length accept. Okay, so this is the DFA where length of string mod 2 equal to 0. Next, see, construct DFA over A and B such that mod W mod 3 equal to 3, means even odd length string. So Q node, Q1, Q2. So there 3 means, mod 3 means number of state must be minimum in minimal DFA. So on input A and B it goes to Q1, on input A and B it goes to Q2. Now on input A and B it come back to Q node itself. Okay, so 0 length it will accept 0 length mod 3 equal to 0, means 0 mod 3 equal to 0. Okay, now 1, 2, 3 length 3 mod 3 equal to 0. Now 3, 4, 5, 6, 6 mod 3 equal to 0. So this is the DFA for the given language. Okay, now construct the DFA where mod W mod 3 equal to 1. So this is the same way that there is state Q node, Q1, Q node. So on input A and B it goes to Q1, A, B, Q2 and Q3. Okay, if Q node will be the final state, that it means mod 3 equal to 0. If Q1 will be the final state, then mod 3 equal to 1. Okay, so this is the required DFA for the given language. Thank you.